All right, so now let's talk about the process of statistics. So if you're trying to do a statistical experiment, these are the steps that you would need to do. So first, identify the problem or the objective, right? If you don't know what the problem is, then you can't actually do a study on it. If you don't know what the objective to the study is, you're kind of wasting a lot of time. Number two, after you do that, then you collect the data. We'll talk about some ways that are correct in collecting data. We'll talk about some incorrect ways of collecting data as well. And actually, some of the most common ways that people collect data these days is actually incorrect. So we'll talk about that in a future video. Number three, we describe the data. So this can be using descriptive statistics, right? So we can kind of talk about using probabilities, or we can kind of maybe show them in a graph or something like that. And then the last one, perform an inference, including reliability. Right? Because remember, we're not 100% certain. So this inference is supposed to be about the population. So we're taking a small group of people, try to see what that might infer about the entire population. So let's look at an example. Problem number 2. The AP National Constitution Center conducted a national poll to learn how adult Americans feel existing gun laws infringe on the Second Amendment rights. Consider a statistical process that would conduct this study. So, first things first, we identify the problem or the objective. So, in this case, we can see that the researcher wishes to determine the percentage of adults who believe gun laws infringe on the Second Amendment rights, right? So, they feel on existing existing gun laws infringe on Second Amendment rights. So, we could say the researchers wish to determine the percentage of adult Americans who feel existing gun control laws infringe on Second Amendment. All right. So, next thing you want to do is collect the data. Now, you don't know this, but the data in this, the way that they collected the data was they did a survey of 1,007 adult Americans. Now, before we continue, let's ask ourselves the question, what is the population in this case? Who are all the people that they are trying to determine the percentage who feel existing gun control laws infringe on the Second Amendment right? So, in this case, the population, everybody that they're talking about is all adult Americans. So, all of the adult Americans. So, to get a sample, we're just going to be looking at 1,007, right? Because we don't want to talk about all 200 million adults. That's way too many, right? So, of these 1,007, they found that 514 believe that the existing gun laws do infringe on rights? We'll just say believe in the infringement, that they already infringe on rights. So number 3, description. So describe the data. So let's give us a little more space. I'm writing a little too big, which is fine. So this can be something as simple as, like we said, finding the probability. So since 514 out of 107 believe that the gun rights are infringing, we can say that of this sample, right, about 51%. Right, when we divide 514 by 1007, we get about 51%. Right, the actual decimal would be 0.50 or 510, which would of course just be 51%. All right, and then number 4, perform an inference. Remembering to include the reliability. So, since we can't be 100% certain, there needs to be some sort of margin of error. And let's say that they want a 3% margin of error. So I made this up. So if you don't know where that came from, I made it up. Don't worry about it. Same with this, right? If you don't know where this came from, I made it up. Yeah, this wasn't a part of the data, so you should not have known this part. And in future like homework problems and test problems, I'll make sure to give you all this. But this was a little too much information on the front end, so I'm kind of giving it to you now. All right, so let's say that we want a 3% error. So to have a performance inference, right, can we say that for 100% certainty that all of 51% of adults, Americans, believe that gun rights infringe on our Second Amendment, right? Gun laws infringe on the Second Amendment rights. Can we be 100% certain that it's 51%? No, right? Like we talked about it, different samples will result in different percentages. However, if we want to have a 3% margin of error, basically what that will mean is you have 51% plus or minus 3%, right? So if you thought about it on a number line, if this is where the 51% was, and we had a margin of error plus or minus 3%, right? Well, plus 3% would be here at 54 when you add 3%. And then subtracting 3%, we would end up with 48. So we are some percentage certain that the numbers are between, right? That our actual percentage of people who feel that gun rights currently infringe on Second Amendment is probably around between 48% and 54%. And again, a lot of this stuff's going to make a lot more sense later on in the semester when we actually see where this margin of error comes from, where all the other numbers come from. But this is about this is what the inference is. We can say that it's going to be about between this number, the entire population. So the population percentage is between these two numbers probably. All right. Let's get down to some more vocabulary. So qualitative data allows for classification. So there are two types of data. There's qualitative data for classification and numerical data for numbers. Or sorry, quantitative data is for numbers. So if it's a category, it's a qualitative data. If it's a number that actually is measured by numbers, then it is quantitative data. So let's look at this. Problem number 3. Determine which one this is. So nationality. So nationality is a type of category, right? It's a qualification. So this would be qualitative data. Number of children. Well, this is something that you would count, right? So it's a number, so we would have quantitative data. Household income per year. Again, this would be a number that you can add and subtract, so quantitative data. Level of education. So, level of education would just be qualitative, right? This would be the just the category, right? You could have your AS, your BS, your master's, high school diploma, right? Daily intake of whole grains measured in grams per day. So again, these would be numbers. So this would be quantitative data. Next, let's talk about numbers on football jerseys. So let's think about this. Would this be qualitative or quantitative? So they are numbers, so we might think it's quantitative. Let's think about this. Do these numbers make sense to actually add and subtract? So for instance, if we look at the number of children, would it make sense to add the number of children together? Well, yeah, right? If one family had 5 children and another family had 2 children, if you added those two together, there'd be 7 children. That makes sense, right? Let's think of household incomes. That also makes sense adding them up. One person has a certain amount of money, another person has a certain amount of money. If you add those two together, that makes sense, right? But let's go to football jerseys. So if a football jersey, if someone has the number 20 and someone has the number 53, if you add those two together, you get 73. What does that tell you about football jerseys? Nothing, right? So this number actually doesn't represent a number in a mathematical sense. It represents more of a category, right? There's a range for each position. And so it's just really a way to classify all of the football players. So this actually would be qualitative data. Yeah, this is a trickier one. Hopefully that made sense. All right, so within the quantitative data, so remember this is numbers, there are 2 ways of getting these, right? So one way you could do it is by counting. That's like the number of children, right? 1, 2, 3, 4, 5. So if you are counting, then this is what we call discrete variables. Discrete variables are found by counting. Continuous variables are found by measuring. There's more complicated definitions, but these are the ways that I think is probably the easiest for students to understand which is which. So if you found the number by counting, it's discrete. If you found the number by measuring, it's continuous. So let's look at these again. So the number of children, well, that's something that you would count, right? So that would be discrete. Washington was 188 centimeters tall. So you don't count the centimeters, right? It's not like you look at the person and you're like, that's 1 centimeter, 2 centimeter, 3 centimeter, right? No, this is something you measure. So this is continuous. Honda Civic has 4 cylinders. So that's something that you would be able to count. So this would be discrete. A female has an arm circumference of 10 inches. So again, this would be continuous because this is something that you would be measuring. An earthquake has a measurement of 0.7 on the Richter scale. Well, you don't count 1, 2, 3, right? It's also a decimal. And it says the word measurement right there. So we know that this is also going to be continuous. All right. Last problem, and then we're done with this section. So the following table presents a group of selected countries and information regarding these countries. Lists the individuals, the variables, and the data. So let's kind of put everything that we've talked about together so far. So looking at this, what are the individuals? Who are the people or the things or the objects that we are studying in this table, from this table? hopefully you can see that we're actually studying the countries, right? These are the list of individuals in this case. And again, individuals can be humans, but it can also be cars, it can be tables, and it can be countries. All right, let's look at the variables. Because remember we said if you're doing some sort of study, the data needs to vary. So what are the variables here? What are we studying? We're studying the government type, the life expectancy, and the population. There we go. Cool. All right. And then now, what types of data are all of these? So, is it qualitative or quantitative? So, which ones are the qualitative data? So out of these three variables, which one is qualitative? Easily, hopefully, we can see that the government type is qualitative, right? That's the one that has categories. All right, so then what's the quantitative type? Well, we see that that's the other two, right? Life expectancy, that's a number. Population, that's a number. So we got life expectancy and population. All right, now, remember we can also break up quantitative data. There we go. We can also break up quantitative data into continuous and discrete. So which one of these is continuous and which is discrete? Or are they both continuous or both discrete? Well, population, this is an easy one, right? How do you find a population? You just count them. So if we're counting, what does that mean? That means that it would be discrete. All right, let's think about this. Life expectancy. So this might be a little trickier. So how do we figure out how old someone is? Well, I mean, you kind of can add their years, but if we're thinking about this, right, the best way to actually determine the life expectancy would be to measure it, right? Essentially, the idea is if you had a stopwatch, right, at their birth, and you let it go until their death, right, that would tell you how old that person was when they died. And this is a way of measurement. Hopefully that makes sense. So since that's a measurement, we know that this is going to be continuous data. All right. That's it for this lesson. If you have any questions, as always, feel free to contact me. Otherwise, have a great day.